Hey guys, this is topic 8, lesson 5, types of reactions. I'm going to go over some different types of reactions that you should be able to identify types of reactions and the names of them. So let's get started. Okay, the first type of reaction is a synthesis or composition reaction. In a composition reaction, what you have here is you have reactants reacting together to make a more complex product. So a reaction of at least two substances that form a new, more complex product. So in this example here, I've got A plus B equals AB. Is a general example here. And a real example would be something like this. Sodium plus chlorine yields sodium chloride. Now, one of my students asked about this structure, and he said, why are we writing 2Na and then Cl2? Why is the 2 in front in this one and in the back in this one? And just as a clarification, I think it's worth going over again. So let's talk about this right now. So for this, what that means, what 2Na means, is that means you have sodium twice. That's what 2Na means. You have two sodiums. And by the way, this is for the reaction. 2 sodiums plus chlorine yields 2 sodium chlorides. So this is what we're talking about right here. So that's 2 sodiums, and it's plus a 1 Cl2. So that means that chlorine is connected to another chlorine, and there's just one of them. That's the difference between those subscripts and superscripts. And this is yielding, what is it yielding? It's yielding sodium chloride twice, 2 sodium chlorides. So as you can see here, we've got 2 sodiums, and we've got 2 chlorines, and at the end we've got 2 sodiums and 2 chlorines. So this is a balanced equation, and what we have here is the matter has just changed organization. So we had the sodiums alone, the chlorine paired up here, and then now the sodiums are bonded with the chlorines. And that's what a chemical reaction is. Conservation of mass is conserved. We didn't gain or lose anything in this process. We just rearranged how things are. So good question, and worth talking about, in my opinion. Okay, so synthesis reactions are like reactions where you've got pieces becoming something more complex. So I think of like bricks being put together to maybe make a brick wall. So the opposite of a synthesis reaction or a composition reaction would be a decomposition reaction. This would be an example of like having a brick wall and then breaking it down into the bricks. So you've got a whole structure breaking into pieces. Real world example of this would be the electrolysis of water. If you take 2 wires and run electrical current through one wire will produce hydrogen gas and the other one will produce oxygen gas. So water, more complex molecule, breaking into 2 less complex molecules. And that would be decomposition reactions. An easy way, by the way, to identify these is synthesis reactions will have more plus signs on the reactant side, where decomposition reactions will have more plus signs on the product side. You'll have more product in a decomposition reaction, more pieces, and in a synthesis you'll have more reactant. Okay. A single displacement, or sometimes referred to as a single replacement reaction, is a reaction in which the atoms of one element take the place of the atoms of another element in a compound. So what you have here is you've got a compound with an element, and you get a different compound. So this was AB compound, you get a different compound, CB, and a different element. So in single displacement reactions, what you're going to see is a compound and an element, and then you'll see another element. What's important to see is you have to identify a lone element. An example of this would be copper chloride, and this would be in a solution like aqueous copper chloride. If you put a piece of aluminum metal in it, the metal will start dissolving, and that metal will start to become aluminum chloride. So the aluminum's still there, it's just going to become aqueous, it's going to be dissolved in there, and then you're going to come out with copper. So you'll see the aluminum will start dissolving, and a copper solid will start forming atom by atom. So it'll be this real silty, fine brown precipitate that you'll see at the bottom here. This is a single displacement reaction. All right, and the next reaction that you're going to need to be able to identify is a double displacement reaction, or a double replacement. In this situation here, unlike the single displacement, you're going to have two compounds. You're going to have two compounds that react together, and you'll get two different compounds. So it's a reaction in which a gas, a solid, a reaction in which a gas, a solid precipitate, or a molecular compound is formed from the apparent exchange of ions between two compounds. So what's happening here, if you take A and AB plus CD, if you think about A switching with C, it's a double displacement, the A and C switch. That means that the A is now with D, and the C is now with B. So they both just did the little switcheroo here. An example of this would be lead nitrate mixed with potassium chromate. These are both soluble solutions, and when you get this, you get a precipitate of lead chromate, and potassium nitrate would be in solution. So this would be a solid here. But the point being is the lead was with the nitrate, and now the lead's with the chromate. The potassium was with the chromate, and now the potassium's with the nitrate. So identifying compounds that are switching the cations with the anions, that would be an example of a double displacement reaction. So single displacement is an element. Double displacement, you'll have an element shown. Double displacement, you'll have two compounds. Synthesis, you have more plus signs on the reactant side. Decomposition, you have more plus signs on the product side. You will have, there's a lot more than those type of reactions, but those are four very, very common reactions that you should be able to identify by the formula in the equation. Okay, the last two I'm going to show you involve energy. Now, every reaction either gains or loses heat energy. So if it releases heat energy, it's an exothermic reaction, and if it gains energy, it's an endothermic reaction. And what I mean by that is that the reactants have more energy stored in their bonds than the products, and as the products are formed, heat has to be released. A good example of this is burning something. If you take a piece of paper, the bonds in the paper, the bonds in the reactants have more energy than the bonds in the ash and the carbon dioxide and water that are released. So the paper has more energy than the ash and what's left over here, and that heat gets released. So if you're around an exothermic reaction, it's giving you heat and you feel warm. The opposite is true with an endothermic reaction. If the endothermic reaction, the products now have more energy than the reactants did. So the most classic example before you got to chemistry that I'm sure that you've seen somewhere in one of your classes before is photosynthesis. In photosynthesis, you have carbon dioxide and water, and they do not have as much energy as the product, which happens to be sugar and oxygen. The sugar has a lot of energy stored in it, so energy has to be added to the system, and that energy comes from the sun. And that's an endothermic reaction. Now, it's worth noting that chemistry books and chemistry questions and physics questions, if you're understanding the basic idea of endothermic and exothermic reactions, you have to think about the system. Is the system gaining energy or losing energy? Now, follow along with me because a lot of people get confused on this. Would boiling water be an endothermic or an exothermic process? Many people think that boiling water would be exothermic because it's hot. So I want you to think about this. Would boiling water, you got water, and now you're boiling it. Now it's kind of violent, it's making bubbles. Boiling water, would this process be endothermic or exothermic? Well, you got to think, to boil water, you're going to have to add heat, aren't you? You're going to have to add a fire. So you're adding energy to the system, and if you're adding energy to the system, this would be endothermic. Endothermic. Okay, so endothermic would be boiling water. A lot of people will want to say it's exothermic because they think boiling water is hot, so therefore it's exothermic. But the reality is boiling water is an endothermic process because it's adding energy to it. The opposite is true for this example here. If you're going to make an ice cube, if you're going to freeze some ice, if you take water and you put it in the freezer and it becomes solid, if you take water, put it in the freezer and it becomes solid, what's happening here? Well, heat is leaving the water and it's going through into your freezer and out the back of your freezer. That's why freezers, they're very hot in the back, because it's removing that heat. So the heat's leaving and then you've got this ice. So freezing of water is an exothermic process. It's an exothermic process because heat is being removed, whereas heat is being added when you boil water. Okay? But if you had a reaction like a heat pack and you activate a heat pack, your hands will start to feel warm, and that's heat leaving the system. And a cold pack requires heat, so it's adding heat to the system, and that would be an endothermic process. So cold packs are endothermic process. So just try to think that about the system when you're trying to determine if things are exothermic or endothermic processes. All right, for the workshop for this one, just a little bit of practice is I just want you to write down these equations and then afterward tell me what kind of reaction is this. So this is potassium chlorate turning into potassium chloride and oxygen. Is that a synthesis reaction, a decomposition reaction, single displacement, or double displacement? You can't tell me if it's endothermic or exothermic just from the information I gave you here, because I'm not telling you if energy is coming in or out of the system. Although all of these are either exothermic or endothermic, but I'd have to tell you something about energy, and we'll get into all the energy aspects later when we talk about thermodynamics. I just want to kind of introduce you to those concepts. So none of these here I want you to worry about exothermic or endothermic. I want you to look at the formulas and try to figure it out. Number 2, iron plus copper 2 sulfate, because sulfate is -2, so that's copper 2, turns into iron 2 sulfate and copper. And the third one is hydrochloric acid is reacting with sodium hydroxide to produce water and sodium chloride. And the final question, predict the products of this synthesis reaction. If I take carbon and oxygen and react it together in a synthesis reaction, what would you predict the product to be? So just a little review on what we're doing here and what kind of test questions or quiz questions you might see with types of reactions here. Good luck. Save your questions for me and we'll talk about them in class. I look forward to seeing you soon. Take care, guys.